right, let's take a look at the rectangle. You'll notice I've done something here. I've listed the parallelogram properties because a rectangle is a type of parallelogram. If you think about a parallelogram's definition is that it has two sets of opposite sides that are parallel. That happens with a rectangle. So a rectangle is a smaller subset of all parallelograms. Its definition is a parallelogram with four congruent angles. Now ultimately what that means is four congruent angles means they are all 90 degrees each, because in a quadrilateral you get 90 in each of those spots. So this becomes our definition is it's a parallelogram with four equal angles. Now that brings about a number of cool relationships inside, which we'll talk about. The first one is about the diagonals. Notice the previous knowledge was diagonals bisect each other, so that's going to happen. These are going to bisect each other. But, actually let me draw that guy again. They're going to bisect each other, but they're also going to be equal, so they split them in the middle, but they will all four be the same. This is really, really important as to the internal guts of this guy, because there are two sets of isosceles triangles inside of here. So what's hiding inside of here are all kinds of things about base angles. Like these will be base angles that would match these ones. And these base angles would be the same and they would match these ones. And guess what? Every one of those corners will equal 90 because it's a rectangle. So the very important thing to remember about a rectangle is that inside of it is these sets of isosceles triangles. And what's fun about that is that you actually can find out quite a bit. If I was to tell you that this was a rectangle, this is a rectangle ABCD, and I give you one angle, watch how many angles I can find. Watch, this is cool. So let's say this is 25 here. This is a 90-degree angle, and so this would be 65 in here. There's my 90. Now, I could do alternate interior. This is 25. I could do alternate interior. This is 65. I got those. I can also talk about that the diagonals bisected each other and they are congruent, which makes all four of those the same. That makes this 65, this 25, this 25, this 65. This is 130, which leaves me with 50 here and 50 here, making this 130 and this 130. I found every angle from one angle. You got to know that kind of stuff and be able to get around in there. I remember one that stumps some students here. Again, you might have where you've got this kind of situation. I think it wants to know, what is this? And it gives something like an angle over here. Well, there's a couple of ways to get there. If this is a rectangle, if I could draw one better, let's say that's our rectangle. Now, I could do a couple of things. I could find that this is 40 here. Now, let me show you this. Not everybody sees this. But actually, this is 80 because the external angle equals the sum of the two remotes. Most students won't see that. What they'll normally do is just say 40 and 40 make this 100 and 100 and this make a linear pair for 80. But it's also true that the exterior angle equals the two remotes. Now, the last thing is that because of those equal lengths in there, some things start to happen. As soon as I drop right angles, I want to warn you that if you're coming across a tricky problem, I bet it has to do with the Pythagorean theorem. Because as soon as you get right angles, you have a right triangle. As soon as you have right triangles, you start to find out things about length. So for instance, if they said that this side was 6 and this side was 8, and they would like to know how big is it from here to here, what I would do is I would say 6 squared plus 8 squared equals c squared. Now that would be the entire length there. And when we solve this, this is 36 and 64, the square root of 100, we find out it's 10. Now 10 though is the entire diagonal. So we would learn that this is 5 and that this is 5. Lots of little Pythagorean tricks if you get caught looking, going, I don't know how to find this, and it's about length. I bet it's a Pythagorean question. Keep your eye on that.